Hi guys, so today we'll be walking over the QUIC transport layer protocol, which is quite new. It was developed by Google. Um, if you look at the packets here, the first frame here, we can see that it's built on top of UDP, User Data Link Protocol, and it uses the UDP port 443. The main purpose of this protocol basically is to minimize the time that it took for a connection to be established to make internet or access to internet really fast. And for that purpose, what Google came up with was like during the handshake, reduce it to between 1 and 3 round trip times. And we can see that because if this is a new connection, then it's only 3 round trip between the client, between destination and the source, only 3 round trips, and the connection was established. Whereas in TLS, we've seen that it takes, we've seen the send and hack frames, and we've seen that it takes a lot of time. Um, After the handshake is done, then the conversation can begin. Of course, it's encrypted right now, but the connection begins. And if we break this down, we can see that it has its own header. And how this works is basically has a destination and a source connection ID. Now, what this basically means is you can treat it as port numbers. So each connection has its own connection ID. So even if you switch networks and you have the same connection ID, the connection can be re-established almost instantly. And that's one of the biggest advantage of this network. Then we have packet numbers and length, which is pretty simple. The length of the payload, and packet number is one that we've gotten rid of the sequence numbers here. So we have packet numbers here, and that's pretty much same for all payload that's been sent. Here you have another one. If you look at the initial header handshake one, you can see that we can see the packet number one, the first one which was sent from the source to destination, and then from the destination, the server to our PC. That's packet number one as well, and then we have packet number two, and that's all the handshake back and forth between the two server and client. Apart from that, there are a couple of things that you can really see here. It's because it's not decrypted, you can't really see the payload and stuff like that. But you can really see how the header comes along. You can see the packet length, the version, and you can see the connection ID length. So the length of this one, the length of the payload, and it also has another short header, which basically contains the remaining of the payload. The QUIC protocol does not support fragmentation, so it cannot be fragmented. Does not have fragmented numbers like we have seen in other protocols. And through this way, we can see that it communicates between two devices. It's currently being adopted by mainly Google, big companies like Google, Facebook, and if you're using YouTube, using Google Chrome, there are great chances that you will be using QUIC. QUIC alongside HTTP3. That's what's being used right now. Um, yeah, I think that's pretty much it for the Wireshark. It has a handshake protocol, but the main purpose of this is to reduce the back and forth that was in TCP, and that's been reduced to only 3. So the TLS handshake has been reduced to only between 1 to 3 round trip times, depending on if it's a returning connection or not. And generally, most of the things that you will see in the tutorial, it's mostly encrypted. Only a few fields in the header you can really